Okay, well, there's a dilemma when we have functions that are multiplying against each other. So we're going to do this new process using U substitution, but the process is called integration by parts. And we need to know several parts. We need to know the U and the dv, which is what we have right here. And then we have to determine the v and the du part, and this is formula. So this is the original thing that we're given. We're going to have a u times a dv, which is what they gave us, a u, and this is the dv. The integral of all of that is we're going to multiply the u times the v whenever we determine what that is. Then we're going to subtract the integral of the v times the du. So that's the process. I have the formula right up there. So let's do it this way. So our u is x. Well, the derivative of x is just 1 dx. Or 1 dx means just dx. Now, they also gave us the dv. The dv, meaning the derivative of v, is ex dx. Well, whose integral is e to the x? Is e to the x. Because if you have y is equal e to the x, the derivative is e to the x times the natural log of the base e, but those cancel. All right, so now we just apply this formula. So we start, so uppercase f of x is equal to, we put the original u times dv So now we have our u function, which is x, our v function, which is e to the x. Now we're going to subtract the integral. So this is u times v, like this formula says. Then the integral of v times du. Well, 1 dx is just dx. And now look at what we have. We have a command to take the derivative. In fact, that parentheses shouldn't have gone there. That parentheses should have gone there. So the integral symbol, dx, means you take the integral of e to the x, which, by the way, is e to the x. And then we can't, since this is the indefinite, we add the integral of antiderivative of 0, because there's an invisible 0 right there. And the antiderivative of 0 is a constant. We just don't know what that constant is. And now we just bring that down. Ta-da! This next one's going to be a little bit more challenging, and then we're going to do one that has one or two that you have to integrate by parts twice. Okay, we have a square root function. That's what our dv is. So let's come over here. I've already started to work it out, but I'm going to have us do it together. So if the dv function is square root of x, or x to the 1/2, well, when we integrate that, remember, we integrate x to the 1/2 dx. So 1/2 plus 1, which is 2 over 2. So now that gives us 3 over 2. So instead of dividing by 3/2, we're going to multiply by the reciprocal. So this would be 2/3 x to the 3/2. So if we take the derivative of 2/3 x to the 3/2, we end up with x to the 1/2, or square root of x. Okay, so we can put v here as 2/3 x to the 3/2, and then our du is 1 over x dx. All right, we have the setup. Notice this time they put it this isn't necessarily the normal order. This is the u, this is the dv, but sometimes this order makes more sense, so don't get too wigged out about that. Remember, 4 times 5 means the same thing as 5 times 4. So u times dv is the same thing as dv times u, which is what we have right here. This is dv times u. And now all of that equals the u times the v. So our u is ln of x times the v, which is 2/3 x to the 3/2, and then we're probably going to rewrite that at the end. Subtract the integral of the v. So this 2/3, I'm going to bring the 2/3 out, and then that's just x. Well, yeah, I'll do that. I'll keep consistent. And then our dx, or du, excuse me, is 1 over x dx. All right. So notice we have this stuff right here to integrate. So what we can bring down is 2/3 x to the 3/2 times the ln of x. All I did was rewrite it like that. We're subtracting 2/3, and now we're going to integrate this stuff. Well, notice here's an x to the 3/2 over 1 over x to the first. Well, x to the 3/2 over x to the first, I'm going to write 2/2. And the laws of exponent tells us when we divide powers of the same base, we subtract. So 3/2 subtract 2/2 is x to the 1/2. So this integral right here ends up being x to the 1/2. And now I can write plus c, and now we can simplify all of that. So square root of x, and I'll put things back in the square root form. That's best practice. So here we have 2/3, and now this x to the 3/2, it's a square root of x cubed times the ln of x. Make sure the ln of x does not get underneath that square root symbol. Then we have subtract 2/3 times x to the 1/2 is the square root of x. Ta-da! All right, now we're going to go down here to do integration by parts, but when there will be you'll have to do it 2 times. So this will be our u, this will be our dv. So if our u is x squared, our du is 2x dx, our dv is e to the x dx, and our v is e to the x. So write down the original. And now it's u times v subtract the integral of v times du, which is 2x dx. Now this 2, we can go ahead and bring out front because it's a constant. Okay. Now look at what we have. We have ex times x, so we're going to have to do this process again. So our u will be x, our du will be 1 dx, or just dx. Our dv is e to the x dx. And our v is e to the x. So we can bring, whoops, sorry about that. Yikes, where did it go? Okay, found it. Okay, so you're all going to get sick of writing so much. Now it's 2 times the integral of all of that. The integral of all of that is this stuff again. So it's uv subtract the integral of v du. So it's x e to the x subtract the integral of e to the x dx. Well, this is pretty easy. The integral of e to the x dx is e to the x. So we can cross this off and substitute that with e to the x, and then there will be a plus c out here. So the final answer will be x squared e to the x subtract 2, I'm going to do the distributive, 2x e to the x, a negative times a negative is a positive, plus 2 e to the x plus c. Ta-da! All right, we're going to do one more. That's, I think, going to be another double. So this is going to be our u, this will be our dv. So our u is x squared, our du is 2x dx. Our dv is, now this one's a little bit tricky. Remember, the derivative cosine is negative sign. So since that's a positive sign, that means our v would be negative cosine, because the derivative of negative cosine would be positive sine. All right, so let's get started. X squared times sine of x, all of that dx, is equal to u, which is x squared, times v, which is negative cosine x, and then this negative sign will bring to in front, subtract the integral of v, which is negative. This negative will come out front, and that'll be a plus sign, times du, which is 2x dx. This 2 and this negative sign will bring negative 2x. That goes away, that goes away. So we will have, subtract a negative becomes positive. That was not supposed to be an x outside of there. Sorry about that. This negative 2, and then subtract a negative becomes adding positive. So now we just have, well, the antiderivative to cosine is, this becomes sine. All right, so let's bring everything else down. So x squared, minus x squared cosine x. Instead of rewriting that, I'm just going to, I should have just, plus 2 sine x plus c. So f, uppercase F, there you go. All right. So integration by parts, when you have to do it only one time and when you have to do it twice, practicing these a few times. And I would start by practicing the same ones repeatedly until it's like, oh, okay, that's easy. Because they do get pretty easy once you get used to it.